Aloha colleagues, welcome to OC 6005, Scope and Methods of Research. The title of this presentation is Quantitative Analysis. Before we begin going over specifics on quantitative analysis, I do want to point out that this is a research design course, not a statistics course. So I know a lot of students are probably wondering why it's necessary to learn anything about analyzing quantitative data. Uh, Many students in the class have indicated that they would like to use surveys as part of their research design in our class project. And statistical analysis can be quite involved. However, we can use some descriptive statistics because they help describe raw data. And specifically, these methods are numerical counts or frequencies, percentages, measures of central tendency such as the mean, median, and mode, as well as measures of variability. So, for example, range, standard deviation, and variance. I will go into detail on these methodologies in the following slides. Let's begin with numerical counts, otherwise known as frequencies in the literature. So counts or frequencies tell us how many times something occurred or how many responses fit into a particular category. So for example, in our analysis, we could say 32 of the participants were over 55 years of age. In some cases, numerical counts are all that's needed or wanted in your analysis and discussion. In other cases, they serve as the basis for other calculations. And for example, one such calculation is the percentage, and we will go into a lot more detail on percentages in the following slides. So percentages are a commonly used statistic. The percentage expresses information as a proportion of a whole. And calculating a percentage for our previous example, we might find something like this. So 85% of the participants were over 55 years of age. In particular, percentages can be easy to interpret. So for example, it's more understandable to say that 40% of the respondents use professional development plans as part of their organization's employee evaluation process than to say that 96 of 240 respondents use professional development plans. Also, percentages are a good way to show relationships and comparisons, either between categories of respondents or between categories of responses. And I'll provide some examples here on the next slide. So I'm going to provide some examples here. So for the first one, 59% of employees in 2009 reported being overly stressed at work on a daily basis as compared to 76 reported being overly stressed in 2016. So this is comparing 2009 respondents to 2016 respondents. In the second example, while 76% of respondents reported being overly stressed at work, only 13% have talked to their supervisors about strategies for better handling stress in their job. So this is comparing responses from the same respondents. So we can see how utilizing these different examples can be helpful in describing your analysis to your audience, whether that's to a client or in a research paper. But interpreting this data, we can begin to paint a picture with our words. Percentages are also useful when we want to show a frequency distribution of group data. The frequency distribution is a classification of answers or values into categories arranged in order of size or magnitude. So the following table provides this example. On the left-hand side of the table, we have place of residence, and in that category we have rural, farm, rural, non-farm, and small town. In the middle column we have the frequency, and in the right-hand column we have the percentage. you'll notice that underneath the table it says Table 1, frequency distribution of employees by place of residence, N equals 860. So when reporting a percentage, a common practice is to indicate the number of cases from which the percentage is calculated. So either the N, a capital N, which is the total group, or the lowercase n, which is the subsample or subgrouping. There are some issues that you need to keep in mind when you report percentages. And the first thing to keep in mind is use the correct base. So the base is the denominator or divisor, and it's the number from which the percentage is calculated. So it's important to use the right base and to indicate which base you've used. So for example, does 75% mean 75% of all participants, 75% of participants sampled, 75% of those who answered the question, 75% of the respondents to whom the question applied? So you can see how there are many ways that you can inaccurately report some analysis statistics. So please be sure that you are correctly reporting your percentages. This also includes reporting no response, especially if it's at a high rate. So if you look at the table on the right-hand side of your slide, we see that out of 100 respondents, 70% of them chose yes, 20% chose no, and 10% didn't respond to the question. So when we have such a high no response rate, it does impact the percentage that we would report in our analysis and discussion. Continuing on with percentages, there are a few things to keep in mind as you conduct your analysis. In terms of rounding percentages, the rule of thumb is that 5 or greater is rounded off to the next higher number. So for example, if your analysis yields an answer of 67.5%, that would be rounded to 68%. In terms of adding percentages, percentages are added only when categories are mutually exclusive, meaning they do not overlap. So this is not the case in multiple choice questions where the respondent may select several answers. And in terms of averaging percentages, avoid the error of adding percentages and taking an average of the summed percentages. This is done frequently, but it's never justified. And I provide an example on this next slide. The example provided here shows the district as well as the projects completed within those districts. In this table, we see that the evaluator incorrectly reported an average of the 6 district percentages. Rather, the percentage should have been calculated by dividing the total number of completed projects, which is 116,000, by the total state membership, which is 165,000, for a total mean percentage of 70%. Sometimes, as in this example, the differences are not great, and other instances the error can be quite large. So it is something. Now we're going to discuss measures of central tendency, and these are used to characterize what is typical for the group. So these are measures which allow us to visualize or identify the central characteristics or the representative unit. So for our purposes, the most likely measures of central tendency are going to be the mean, median, and mode. And we are going to discuss these in depth in the following slides. The mean, or the average, so it's known as both, is commonly used in reporting data. It's obtained by summing all the answers or scores and dividing by the total number. The mean is also useful for summarizing findings from rating scales. So in this particular example, we have 3 items or questions, and we have a 4-point Likert scale, meaning we have 4 options, which are poor, fair, good, and excellent. And what we've done is we've assigned a number to each of those 4 things. So poor is equal to 1, fair is equal to 2, good is equal to 3, and excellent is equal to 4. I am going to go over an example calculation in the next slide, but this is the example that we're going to be utilizing. So you may need to rewind this presentation and come back to this slide just to review it. So we can determine the mean rating for each item by calculating or multiplying the number of answers in a category by its rating value. So poor is equal to 1, fair is equal to 2, etc., etc. Obtaining a sum and dividing by the total number of answers for that item. So to calculate the mean for the first item in the previous example, we're going to follow these steps. So step number 1, multiply answers by value. Step 2, we're going to sum our answers from part 1. And third, we're going to divide by n, so the sample size. So here we find that 3.2 is the mean rating for those 3 questions. Unfortunately, a disadvantage of the mean is that it gives undue value to figures at one end or the other of the distribution. Moving on, we're going to talk about the mode. The mode is the most commonly occurring answer or value, and the mode is important only when a large number of values is available. It's not as affected by extreme values as the mean is. The median is the middle value, so it's the midpoint where half of the cases fall below and half fall above the value. In order to calculate the median, first you're going to arrange the data from one extreme to the other. Next, proceed to count halfway through the list of numbers to find the median value. And finally, when 2 numbers tie for the halfway point, take the 2 middle numbers, add them, and divide by 2 to get the median. So like the mode, the advantage of the median is that it's not as affected by extreme values or range in data. Here I've provided an example of the mean, the median, and the mode. So this example looked at 10 families and their income in the year of 1991. And we see that the mean is 55,000, the median is 35,000, and the mode is 30,000. So we do see a bit of variability in the answers here. Overall, the mean is most likely to be the most popular way of describing your data in terms of descriptive statistics. You'll see it the most. At this point, we are going to discuss measures of variability. So measures of variability express the spread or variation in responses. As indicated earlier in our presentation, the mean may mask important differences or be skewed by extreme values at either end of the distribution. For example, one high value can make the mean artificially high, or one extremely low response will result in an overall low mean. So looking at variability often provides a better understanding of our results. So for example, are all the respondents and responses similar to the mean? Are some very high or very low? Did a few do a lot better than the others? So those are good questions to ask as we look at our data. So several measures can help describe the variation we might find in our evaluation results. And these measures include the range, the standard deviation, and the variance. And I will go into detail on these measures in the following slides. The range is the simplest measure of variability. It compares the highest and the lowest value to indicate the spread of responses or scores. It's often used in conjunction with the mean to show the range of values represented in the single mean score. So the range can be expressed in two different ways. First, by the highest and lowest values. So an example would be the scores ranged from 5 to 20. Or the second way, with a single number representing the difference between the highest and lowest score. So, for example, the range was 15 points. While the range is a useful descriptor, it's not a full measure of variation. It only considers the highest and lowest scores, meaning that the other scores have no impact. The standard deviation measures the degree to which individual values vary from the mean. It is the average distance the average score lies from the mean. So a high standard deviation means that the responses vary greatly from the mean. A low standard deviation indicates that the responses are similar to the mean. And when all the answers are identical, the standard deviation is 0. And I've provided here the formula for calculating the standard deviation. In terms of the variance, sometimes instead of the standard deviation, the variance is used, and it's simply the square of the standard deviation. So this formula will look very similar to the standard deviation formula because it is simply squaring the standard deviation formula. So at this point, we will be working with the data or whatever your survey results may be. So to begin to understand your data, look at the summary of responses to each item. First off, are certain answers what you expect? Do some responses look too high or too low? Do the answers to some questions seem to link with responses to other items? So this is the time to work with your data. Look at the findings from different angles. Check for patterns. Begin to frame your data into charts, tables, lists, and graphs to view the findings more clearly and from a different perspective. So a good process is to summarize all of your data into tables and charts and write from those summaries. See how the data look in different graphic displays. This is about which displays will most effectively communicate the key findings to others. So I do have some concluding thoughts. The possibilities for analyzing your evaluation data are many. So give priority to those analyses which most clearly help summarize the data relative to the evaluation's purpose and which will make the most sense to your audience. Please let me know if you have any questions. I'm only an email away. And if it's a question I think the entire class can benefit from, I will post it as an announcement. I will leave your name off, of course, but that way everyone can benefit from the question and the answer. Have a great week.